Well, now let's take a look at example number 7. I'm going to ask you actually right at the start here to see if you can use all the things that we've talked about thus far in this section to see if you can answer this question on your own. Go ahead, see if you can try to answer it to the best of your ability, and if you get stuck, don't worry about it. But pause the video here, and when you hit unpause, you'll see me work through the solution. Okay, so hopefully you spent some time to try to work through that solution. Let's see what we would have. One of the first things that I might notice here is that I do have a nice rational function, which means I could just direct substitute. That's going to be amazing. So notice if I direct substitute here, the top is going to turn into, let's see, 25, that would be 25 minus 15 minus 10. The bottom's going to be 25 minus 50 plus 25, and that's 0 over 0, shoot. Am I actually allowed to direct substitute here? No, I can't do that. So I'm going to go ahead here and instead state the following. I'll go ahead and state that we cannot direct substitute because we get 0 over 0. But remember, when we get 0 over 0, we can try to simplify. Okay, so let's see. So the limit as x approaches 5, x squared minus 3x minus 10 over x squared minus 10x plus 25. How could I possibly simplify this? What options do I have? Oh, well, one option that I have is maybe to try to factor that numerator and that denominator. So the numerator can factor into x minus 5 and x plus 2. The denominator turns into x minus 5 and an x minus 5. Of course, this is convenient because an x minus 5 from top and bottom can simplify out, but it's also not that convenient in that I think I'm still going to have a slight problem here. Notice that what I'm going to be left with now is still a rational function, so I could try to direct substitute again. But you can probably tell what you're going to get when you direct substitute. On the top you get 7, and on the bottom you get 0. And so again, I still cannot direct substitute. So I'll say we still cannot direct substitute because we get 7 over 0. And that's not okay. So remember, if I get something like this, like a number over 0, what I'm going to do is check the limit from both sides. Okay, so let's see how we can do this. We have space on the next page to try to get it done. So here's my first limit. Let's take a look at what happens as I approach 5 from the left. And I'm only going to work with this x plus 2 over this x minus 5. And here's again where I'm going to kind of use these arrow arguments. I'm going to think about what the top is moving towards and what the bottom is moving towards. Now you got to think through this. This isn't something where you just make up numbers here. There's a thought process here. So think carefully with me. Really try to think it through. Let's suppose that I have numbers that are on the left side of 5 on the number line. Okay, so here's 5. Imagine I take numbers that are on the left side of it on the number line. Now, if those sorts of numbers are going in, what is the top going to be getting close to? Well, you could definitely say the top is going to be getting close to the value of 7. I'm even going to mark, though, that it's going to be a little bit below 7, right? Because if I plug in numbers a little bit below 5, then that's like, I don't know, 4.9-ish, right? Somewhere around there. 4.9 plus 2 is like 6.9. I get something a little below 7. Now, in the denominator, I have to think about this as well. Notice here, if I plug in a value that's a little bit smaller than 5 into here, what sort of number will I get back? Well, first I'm going to get something that's close to 0. But will it be a little bit bigger than 0 or a little bit smaller? Notice I have to think about that by actually thinking about doing the arithmetic. If I plug in a number that's a little bit smaller than 5, maybe like 4.5, into here, would I get a negative number or a positive number for the denominator? I would get a negative, so I would be able to mark this as something smaller than 0. Now overall, when I think about where this heads, notice I have a number a little bit smaller than 7 divided by a number that's a little bit smaller than 0. A number that's a little bit smaller than 7 is positive. A number that's a little bit smaller than 0 is actually a negative number. So I have a positive over a negative. My result should be negative. And when I take a number like a 7 and I divide it by something close to 0, I know I'm going to get a really big result. So I get negative infinity. Now that process can be a bit confusing, but let's try it again, now approaching from the right. Again, I have to think through what's going to be happening here. This isn't something where you can just, memorize what numbers to put where. You have to think about it uniquely every time. So let's think. What if I took a number a little bit bigger than 5, something over here, and I plugged it in for x, right? Well then, in the numerator, I would get something close to 7, but probably a little bit bigger. In the denominator, if I plugged in something really close to 5, the denominator would be really close to 0. But if this thing was a little bit bigger than 5, maybe say like 5.1, and I plugged that in the bottom, am I going to get a negative or a positive result? Well, this time I would get positive. It does not, so now I can see that I'm going to have something that's positive over something that's positive, and I'm going to end up here with a positive infinite as a total result. So now I can go ahead and actually see my conclusion very, very simply. The limit of my x squared minus 3x minus 10 over x squared minus 10x plus 25, this limit here, again we can see, does not exist. Okay, so it's really important to note here, and I'll make this point one more time, is just that I have to think through this middle step here. I really have to think about it. You can't reach this conclusion by a shortcut. And here are some of the shortcuts that people often will incorrectly try. They don't work. They're not actually shortcuts. Sometimes people will say, hey, Kyle, this had a little plus on it, so these have little pluses. This has a little minus, so those have little minuses. Sometimes that will work. Other times it won't. It's totally possible that just because this is positive, maybe these come out minuses. Maybe one comes out positive and one comes out as a minus. You have to think it through. So if you need help thinking it through or you're not entirely sure, I might suggest that you re-watch a portion of this video where I was explaining how we determine whether those are positives or negatives. And then you could try to practice some of those ideas on the worksheets.